All right, let's dive into one of the most exciting shifts happening in AI right now. We're talking about the move from AI that just, thinks and talks to an AI that can actually do things. This is the story of how AI is learning to get its hands dirty and solve real-world problems. I mean, we've all been blown away by AI generating incredible text, images, even code. But what if it could take that next giant leap? What if it could actually interact with software, search the web, and carry out a whole plan to book your vacation or debug a program all by itself? That's the huge question driving this next wave of AI development.
And the answer to that question? Well, it's the AI agent. The easiest way to think about it is like this. For a long time, AI has had this brilliant voice, but no hands. An AI agent, well, it gives the AI a set of digital hands. It lets it use tools, click around on websites, and really interact with the digital world to get stuff done. And that gets to the core of what's known as the brain in a jar problem. Right now, we have these unbelievably powerful AI models. I mean, their reasoning ability is phenomenal, but they're kind of isolated. They can't directly act on their own conclusions. They can tell you exactly how to do something step by step, but they can't actually do it for you. So how do we fix that? How do you get the brain out of the jar? Well, let's meet LongCat. It's a powerful new AI agent designed by a team of researchers to do exactly that, to break out and start acting.
So its full name is, get this, LongCat-Flash-Thinking-2601. Yeah, we're just going to call it LongCat. It's an open source model from the Meituan team, and it was built from the ground up to master these agentic tasks. The actions that finally bridge that gap between thinking and doing. And look, the results really speak for themselves. These are benchmark scores, and you definitely don't need to be a data scientist to get the story here. The green bars, that's LongCat. It's just consistently outperforming other top models in all the important skills, like coding, using tools, and searching the web. It's a huge step forward.
Now, this kind of performance is backed by some serious horsepower. LongCat is a mixture of experts model, or MoE. You can think of that as having a whole team of specialized experts on call instead of just one generalist brain. And with a staggering 560 billion total parameters, this thing has the raw power it needs for some seriously advanced reasoning and action. Okay, so that's the what. The really big question is how? How do you actually teach a brain in a jar to act in the world? What's the secret sauce here? Well, it all comes down to a really clever training framework. The researchers themselves put it perfectly in their paper. The key phrase here is adaptive interaction. See, it's not just about thinking in a vacuum. It's about being in this constant loop of thinking, then acting, then getting feedback from the digital world, and then adjusting your plan. It is quite literally learning by doing. They broke down their training process into 3 big steps. First, they had a problem. There's almost no data out there of AIs interacting with tools, so they had to create it from scratch. Then they needed a place for the AI to practice, a massive one. And finally, they used reinforcement learning to hone and perfect its skills. So for that first step, creating the data, they used this brilliant hybrid approach. On one hand, they pulled from unstructured text, things like online tutorials. That gave them a huge variety of tasks. But to make sure the AI learned logical, correct steps, they also generated data from executable Python code. That guaranteed that every single action was verifiable and made sense. Okay, so now you've got the training data, but you need a place for the AI to actually practice. And we're not talking about one little digital sandbox here. To learn truly general skills, this AI needed a massive, sprawling digital playground, almost like a giant library of video games, where each game teaches it a totally different skill. And when I say massive, I mean it. The scale of this playground is just immense. They built over 10,000 unique training environments across more than 20 different domains, everything from file systems to retail databases. And at its peak, their system was running 32,000 of these simulations at the same time. The AI was just learning at this incredible pace. But here's the catch. Training an AI in a perfect, clean, digital world is one thing. But sending it out into the messy, unpredictable real world, that is a whole other challenge. See, in those training simulations, everything works just like it's supposed to. The tools are reliable, the websites load perfectly, the data is clean. It's basically the ideal scenario for learning the fundamentals. But the real world, as we all know, is full of errors.
It's got unexpected API changes, laggy websites, noisy data, you name it. An agent that was only trained in those perfect conditions would just fall apart the second it hit a real-world snag.
So the researchers did something incredibly smart. They deliberately messed up their own training environments. They systematically injected all sorts of noise and errors into the simulations. It's kind of like a flight simulator that doesn't just train a pilot for a clear, sunny day, but also for thunderstorms, engine failures, and broken instruments. It makes the final model way more robust and ready for anything.
All right, and that brings us to the final key innovation here, a special feature that lets the agent basically think harder whenever it gets stuck on a really tough problem. The model basically has two gears. In standard mode, it works fast, finding a solution along a single logical path. But when you switch on heavy thinking mode, it totally expands its reasoning. It's like a chess master who doesn't just think about their next move, but explores multiple different strategies and all their consequences several moves ahead before finally picking the absolute best path. And the payoff for that is huge. This deeper, multi-path exploration gives the model the extra oomph it needs to crack the most complex reasoning puzzles and agentic tasks, the kind of stuff that would totally stump other models. So if you're going to remember just 3 things from all this, let it be these. First, the incredible power of scaling up the environment, using those vast digital playgrounds to teach general skills. Second, building for reality, training the AI with noise and imperfections to make it tough. And third, the ability to think deeper with a heavy thinking mode to crack the hardest problems. When you put it all together, the crucial point is this. We are really witnessing the evolution of AI in real time. It's moving way beyond being just a fancy text generator. It's becoming a true problem solver, a partner that can actually help us get things done in the digital world. And of course, this leaves us with a really fascinating and kind of huge question for the future. As these AI agents get even more capable and more reliable, what are we going to ask them to do next? What complex, messy problems that seem impossible today will become trivial for an AI agent to solve for us tomorrow?